last one, why is this last one so important? Because it's expected value and it's slightly different looking than what we've done before, but it still comes down to this. Expected value is P times A and then add them all up. Probability times the amount that you get, and then you add those all up. Always look for that. Good. All right. This little one, you're playing a game where you reach into a box and you grab an envelope, and the little chart over there tells you the probabilities of you winning when you open your envelope. Okay? Well, my first thought as I look at something like this is that only adds up to 32.32 chance of winning. How is that possible? Yes. Exactly. The one that I left blank here is $0, and you get, well, what's the chances of doing that? Well, if these three add up to 0.32, that must be what? 0.68 chance that you're going to win nothing. Your envelope will have nothing in it. All right. I really like to have a list of all the things that are possible before I start. And then I've got to take the probability times the amount and then add them all up. Well, this times 0 isn't going to be anything. So I really didn't even have to have it there. But I just wanted you to understand because it didn't look complete to me anyway. All right. So now do P times A, multiply them all out, add them all up, tell me what you get. Somebody already did it quick in their head. This times this made $1, right? 5 cents times 10 is 50 cents. 5 times 2 is $1. Is it? Yeah, it's $1. So it's $1, and $1.50 is $2.50. Now, are you ever going to actually get an envelope with $2.50 in it? No. So the expected value is not what you really expect to get. It's an average of what you'd expect to get if you did it a bunch of times. Okay. So that it can help you set the fair price, though. If you were there and you were interested in playing, if it was only $1 to play and you calculated this out, would you think it'd be a good idea to play? Yeah, you probably, if it only costs $1, that's a good deal. Generally, these things, though, your instinct of no, it shouldn't be a good deal is right, because they usually price them to be a bad deal for you. You're expected to lose. So what would they probably price it at? $3, $4 maybe. If they charge $3, they could say you'll always win more than what you paid, right? If you win, you'll always win more than what you paid. Okay, so your $3, well, you're either going to get 4 or 10 or 50. They won't probably talk about the 0 too much. All right. Now, given that somebody won, that's this one down here, what's the probability that they won $10? It'd be really easy for somebody to say, oh, $10, 0.05 is a 5% chance, 0.05. That'd be wrong. Given that they won changes what's possible, right? So what is on the bottom? Then your answer will be totally different. Okay. All right. Moving on to the next one. This one, I did not tell you. Oh, wait. A question on the last one? Okay, go ahead. Okay. That's a good question. But when I say you won, I was implying you actually got something. So winning, being able to draw out is not really winning. Drawing one out and actually getting something is winning. All right. You make a good point, though. On to this next one. I'm not going to be telling you on the test, use binomial on this one, or use a tree on this one, or use blanks on this one. You got to be thinking about those little keys that I was telling you along the way. Blanks are when you want to rearrange things. Binomials when you'd have a great big tree, it'd be nasty to make. The pizza problems or the card problems usually had C's in them, those combinations. Which would work for this? It's actually more than one right answer. Binomial would work because you could make a great big tree that would be 80-20, and you just keep making it. It'd always be 80-20. There's only two things. That's the by that can happen, and the numbers stay the same each time. That means they're independent. So you can do binomial on this, and it'll save you a ton of time. Would you please set up the binomial for this last one? It's the last one for the day. Binomial. Yes.
Except it just went to the fourth power. Like we got last question, can you ever calculate this?
The question is there other ways that I'd accept you doing it? Yes. Just show me your work. If you showed me your work, you're fine. Now, if it says specifically, draw a tree, that means I will be grading the tree. But if it just says answer the question, show me your work, you can do it other ways. All right, this one, I've got 4 seeds, and it seems like I'm focusing on the ones that germinate. So I'm going to put that first. The other is not. And how many germinate in this problem? At least 1. Well, I'm going to put 1 and just see if that works. 0.8, 0.2, 1, and 3. This would not work. That's the probability of 1, not at least 1. That's good for 1. I'd make one just like this for 2, and for 3, and for 4, because at least 1 means 1 works, or 2, or 3, or 4. But that's a lot of work. Instead of figuring out what the probability of 0 germinating, 1, 2, 3, 4, and adding up all of these, I could just figure out the probability of 0 germinating, and then what? Subtract from 1. So I would do this. 4 choose 0, 0.8 to the 0, 0.2 to the 4, and then subtract it from 1. That'd be a smarter way to do that one. But if you want to do this one, at least 1 would mean you'd have to figure out 1 and 2 and 3 and 4 and add them all up. That would work too. All right. Make sure you do some studying tonight. This is not an easy test. It's happening tomorrow. I'll be here in the morning if you need extra help. Have a good day.